Hey guys, today we're talking about angles and lines cut by transversals. So let's review perpendicular lines. These form 90-degree angles. Okay, so you have two lines intersecting and at each angle it's a 90-degree angle. Parallel lines are lines that never intersect, so they'll stretch on and on forever without intersecting. And they have these angle markings, arrow markings that show that they are parallel. We already know a straight line measures 180 degrees. So if we have a supplementary line, then we have two angles together that equal 180 degrees. So angle 1 plus angle 2 equals 180 degrees. If we have a right angle, it measures 90 degrees. So a complementary angle forms a corner like the 90-degree angle, and these two angles together equal 90 degrees. So angle 3 plus angle 4 equals 90 degrees. Make sure you pause the video and take some notes on that. Let's look at vertical angles. Vertical angles form when two lines intersect. These are the angles that are across from one another. They also equal one another. So angles 1 and 3 equal each other, while angles 2 and 4 equal each other. These pairs are called vertical angles, and they are always opposite one another. They do not share a common side. In this slide, I want you to take a second, pause the video, and copy these down, okay? You don't have to copy them verbatim, but make sure that you at least have this picture drawn and take some notes on each one. Okay, so a transversal is this line right here. It cuts two parallel lines, and they form these four angles on each line. So a total of 8 angles are formed by a transversal. The interior angles, for example, 4, 3, 5, and 6, are these angles inside the parallel lines, while the exterior angles, 1, 2, 8, and 7, lie outside of the parallel lines. Alternate interior angles are angles like 4 and 6. They measure the exact same and they lie on opposite sides of the lines and they are alternating. So 4 is up here while 6 is on this one. They are the exact same measure. Angles 5 and 3 also are the same measure. If we look at exteriors, angles 1 alternates with angle 7. They measure the same, while angle 2 alternates with angle 8, and they also measure the same. Corresponding are ones that we can move, like slide up, like 8 and 4. Do you see how they correspond with one another? These two are measured the same, while angles 2 and 6 also correspond. They slide down and form the exact same. So angles 1 and 5 do that, and angles 3 and 7 also do that. So they're in the exact same position on the two lines of the transversal, they're just on a different parallel line. So find the measures of the angles. For example, if we look at this one, he is a vertical angle with 7. So we know 7 right off the bat is 137 degrees. We know that each line right here forms 180 degrees. So if we look at 137 and angle 6, they're on a supplementary line. So we can take angle 6 plus 137 and set it equal to 180. So you know if you take 137 away, angle 6 equals 43 degrees. You can justify then that angle 8 is also 43 degrees by either vertical angles or that 137 and angle 8 also form a supplementary line. Go ahead and try this one, and I'll be back in just a second to show you what I did. Angle 10, you could say, is 54 degrees based on vertical angles, which means angles 9 and 11 are 126 because they form supplementary straight lines with angle 54. So angle 9 and angle 54 form 126, while angle 11, let's use a different color here, with 54 also forms a straight line at 126. So now let's talk about reflex angles. These are angles that form what you would consider a circle with one another. So in this case, we're looking for this outside angle. They measure in between 180 degrees, or that straight line, but less than your full 360 degrees because that's an entire circle. So the reflex of this angle of 38 degrees is 322 degrees because you can take 360 and subtract 38 degrees. In the next one, I want you to see if you can figure out what the reflex angle is. Okay, so take a second, think about it, plug in your calculator. So we're looking for this outside angle here. So take 360, subtract 115, and this reflex angle is 245 degrees. Naming these angles. In this one, name the complement of ADB. So what they're saying here is this is the angle ADB. Okay, so they're talking about this angle right here. So the complement would be angle BDC. We start with one of the angles on the edge, and we always use the inside angle as our middle letter. Okay, so this forms at that vertex point, so our vertex is always in the middle. Do me a favor and find the measure of each angle here. We know that the corner is formed here, which is a complement, and that is at a 90-degree angle. So let's see if we can figure this one out. Go ahead and try it, and I'll be back in just a second to show you what I did. Okay, so here's my work. I'm going to set these two angles added together equal to 90 degrees. So we get 5x plus 15 equaling 90 degrees. If I take 15 away from both sides, I'm left with 75 degrees over here equaling 5x. If I divide by 5, I'm left with x equaling, so x equals 15. In this one, name the supplement of QRT. So we've got QRT. Who's its supplement? If you look, go ahead and try to name it, and I'll be back in just a second to show you what I did. So to name this one, you're going to start at one of these points. I just start with T because that's where they left off. Put in the vertex, and then the final one. So angle TRS. Okay, so let's look at this one. A furniture designer built the bookcase shown over here. Line A is parallel to line B. So if measure of angle 2 is 105 degrees, find measure of angle 6 and angle 3. Okay, so let's justify our answers as well. So if we look at this, this is a supplementary straight line. So we can tell that angle 6 should be 75 degrees. So angles 2 and 6 are supplementary. The sum is 180. So if we take it away, we get 75. Since angles 6 and 3 are interior angles and they alternate, then they lie on the opposite sides of the transversal, then we also know that angle 3 is also 75 degrees. See if you can come up with the remaining angles for me, okay? Try to justify it as you go. I'll be back in just a second to show you what I did. Okay, so if we look at these, anything that's a vertical angle I like to use. So this would be 105 because of vertical angles. Angle 6 would, and 1 would be vertical angles of each other, or 75 degrees. You could also use supplementary as long as they lie on the same line. For example, like 3 and 7 are supplementary 105, or you could say angles 2 and 7 are alternate interior. Could you say alternate exterior? Yep, 1 and 8 are alternate exterior, while 105 with angle 4 is also 105, okay? Let's look at another example. Here's some new things. If we look at a triangle, the measures of all of their exterior angles of the triangle equal the two interiors. For example, If we look at angle 1, we know that he forms a supplementary angle with this angle right here. So if they are 180 and a triangle is also 180, then we know that measure of angle A and B together equals measure of angle 1. Okay, so in addition, now this only works for, like, example, angle 4 with angles 3 and angles 2. It's got to be the ones that are not attached to it. So if we look at angle 6, who would go with angle 6? Angles 1 and 3 would be able to be added together and equal angle 6. If we looked at angle 5, it's not angle 3, it's angles 1 and 2 added together to give you angle 5. So suppose measure of angle 4 is 135. Find the measure of angle 2. Well, we know measure of angle 4 is the same as K with angle 2 together. So if we know angle K is 90 degrees, we don't know the measure of angle 2, but we know together they equal this 135 degrees. So take 90 away, and we're left with angle 2 equaling 45 degrees. Go ahead and try this one down here, and I'll be back in just a second to show you the answer. Okay, so you know angle 5 is 147 degrees. You know that angle K with angle 1 gives you that 147 degrees. So 90 degrees plus angle 1 equals 147 degrees. Take 90 away from both sides, and you're left with 57 degrees. Okay, let's go a step further and prove this then. So we said angle 1 was 57 degrees. Oh, I wrote 77. Just kidding. 57. Okay, angle K is 90 degrees. So what does that mean for angle 2? If we were just looking at it from a triangle perspective, that would mean it would be 33 degrees. Which is also proven by the fact that the angle 5 with angle 2 is supplementary, and 147, if you take that away from 180, is also 33 degrees. So you can prove that this is also true based on supplementary angles and the laws of triangles being 180 degrees. Okay, so now let's get into the things that you're actually going to use this with. Questions like this. These are what you're going to see on the test. So go ahead and try this, and I'll be back in just a second to give you a little bit of help, and make sure that you justify. Give some reasonings for each one. All right, so you know measure of angle 3 is 64 degrees. You also know measure of angle 5 is 90 degrees. You can look at these two and use these to help solve all the remaining. So you could prove that angle 2 is vertical with this 90-degree angle, and you can prove that angle 4 is supplementary with these because they are both on angle M. So if we do the math here, angle 4 is 26 degrees. Okay, so what does that mean for angle 6? Angle 6 is vertical with angle 3, so that's 64 degrees as well. And angle 1 is vertical with angle 4, so that's 26 degrees. Okay, so now how do we get over to this line of N? Well, if we look here, angle 3 forms the same angle as 8. Think back to what that is. Based on corresponding angles, so that's 64 degrees. Then vertical angles lets you do this one as also being 64 degrees. Which means if we follow the laws of supplementary angles, you can find angle 9 at 116 degrees, and angle 7 is vertical, so that also stands firm. So we were able to justify all of those based on just knowing this angle at 64 and this angle at 90 degrees. Let's look at one more. Stick with me, okay? So how do we figure out the missing variables? Go ahead and try this one, and I'll be back in just a second to show you what I did. So you're looking for W, X, and Y. All right, so if we look at this one, angle 78 is vertical, so W equals 78 degrees. If we look at angle 64 here, it forms a supplementary line, so angle X is 116 degrees. Now, think back to our quadrilaterals. We know they equal 360 degrees. So we're going to add up all the angles inside, 78, 116, 82, and y, and set them equal to 360. When I add up my like terms, all of those integers, we get 276. When we take 276 away, y equals 84 degrees. So we know y equals 84 degrees. What do we know about z? They're vertical, so z also equals 84 degrees. And that's all I've got for you. See you next time.